computer network CS8591, Unit 3, network layer. Problems in Unit 3 are: first problem, a classless address is given as 167.199.170.82 bar 27. We can find the above three pieces of information as follows. The number of address in the network is 232 minus n, that is 25, that is equal to 32 addresses. So we can find the first address as well as the last address. The first address can be found by keeping the first 27 bits and changing the rest of the bits to zeros. So now the given address is 167.199.170.82 bar 27. So we'll take the first 27 bit. So we'll keep first 27 bits, and the first address is this, right? So 1010011 8 bit, then another 8 bit 16 bit, another 8 bit 24 bit, 25th, 26th and 27. So we will keep first 27 bits as such, and we will change the rest of the bits as zeros. So this is the first address of the given classless address, and the last address can be found by keeping the first 27 bits and changing the rest of the bits to ones, right? Similar to that. So the address given is 167.199.170.82 bar 27. So we will keep the this is the binary equivalent of all the bits. This is 167, 199, 170, 82, and the last addresses we will keep the first 27 bits as such, and the last 5 bits are we are changing this as 1. So this is the last address for the given classless address. We will go to the second problem. The second problem is, now the classless address is given as 167.199 plus 170.82 by 27. We are going to find the mask. So the mask is in dotted decimal notation is 256.256.256.224. So the AND, OR and NOT operation can be applied to the individual bits. So number of addresses can be calculated by NOT of mask, the complement of mask plus 1, right? So the complement of mask is, this is our mask, 256, 256.256. So complement of this is 0.0.0, and here the number is 224, and the complement of 224 is 31 plus 1. This gives the, that is 32 address. This gives the number of address at the block, and we will find the first address by the given address and operation with mask. So the individual bytes are masked using the AND operation. So the address is 167.199.170.82. This is ANDed with 256.256.256.224, that is the mask. This gives the first address. Now the first address is 167.199.170.82, and we can find the last address by OR and NOT of the mask. So the address and NOT of the mask, complement of the mask address is odd, and we will find the last address. So the last address is 167.198.170.255, right? This is how we are finding the number of addresses in the block by using NOT operation, and the first address by using AND operation, and the last address by using OR operation. We will go to the third. Now the third problem is, an organization is granted a block of addresses with the beginning address 14.24 byte 74.0 bar 24. The organization needs to have 3 subblocks of addresses to use in its 3 subnets. 1 blocks of 10 addresses, 1 subblock of 60 addresses, and 1 subblock of 120 addresses. Now we are going to design the subblocks, all the 3 subblocks. Let us take the first one. the number of addresses in the largest subblock which requires 120 addresses. So 120 is not a power of 2. So we will allocate 128. This is power of 2. We will allocate 128 addresses. The subnet mask for this subnet is can be found out by N1, that is 32 minus log of 128, that is 25. So the first address in this block is 14.24.74.0/25 and the last address in this block is 14.24/74.127. Is it right? So these are the 120 addresses in a largest subblocks, and we will go to the second one, subblock which requires 60 addresses. This number 60 is not a power of 2. So we are allocate 64 address, and the subnet mask for this subnet can be found as N2 is equal to 32 minus log of 64 to the base 2, that is 26. Is it right? So the first address is 14.24.74.128/26 and the last address is 14.24.74.191/26. First address is 128 and the last address is 191. And the third case where we are having the smallest subblock. So the number of subblocks in the smallest subblock is which requires 10 addresses, and 10 is also not a power of 2. So we are allocating 16 addresses. The subnet mask for this subnet is can be found by N3 equal to 32 minus log 16 to the base 2, that is 28. The first address in this block is 14.24.74.192. So it is ended with 191 and here it is 192/28, and the last address is 14.24/74.207. So these are the addresses in the third one, right? We will go to the next problem. IPv4 packet has arrived with the first address. First 8 bit is 010010. So the receiver discards the packet. Why it discards the packet? This is an error packet. How we have found out this is an error packet? The leftmost 4 bits, that is 0100, shows the version which is correct, right? The next 4 bits 0010 shows the invalid header length. 2 into 4 is equal to 8, right? It is an invalid header length. The minimum number of bytes in the header must be 20. So the packet has been discarded or corrupted in the transmission. Is it right? So the next problem. If an IPv4 packet, the value of H length, header length is 1000, how many bytes of options are being carried out by this packet? So H length is 8, 1000, that is 8, which means that the total number of bytes in the header is 8 into 4 is, or it is 32 bytes. The first 20 bytes are base header and the next 12 bytes are options. Then the last H length of TCP is 0111. Find the number of bytes of option included in the segment. In TCP, if the H length is 011, this is binary number 7. So how many byte of options are included in the segment? This means that the header length is 7 into 4, that is 28 bytes. So first 20 bytes are base header and the next 8 bytes are option field. Thank you. Thank you very much.